This is part 2 of the lesion drawing tutorial. Hopefully you've taken a look at part 1, and also hopefully you've downloaded the MRIcron workshop materials. First we're going to go into that folder, see the link in the description for how to download it, and we're going to go into the Brain Lesions folder and open the Lesion Drawing Guide, and we're going to go through the second part of this lesion drawing guide. We can scroll down to part 5 where we left off. We had gone through how to draw lesions and how to set the parameters for drawing those lesions that are included in the materials. And now we're going to go over combining lesions by overlaying them and viewing them in different ways that will be informative. The next thing we want to do is open MRIcron, and so I'm going to go into the MRIcron Windows folder and select MRIcron. If you don't have MRIcron, based on recommendations from the previous video, see the link in the description. And so I'm opening it up. So in order to overlay drawn lesions, instead of having the brain with a lesion in it, so this brain that I have loaded here actually has a lesion in it. What we want is a template brain. And so I'm going to go to File, Open Templates, and open the CH2 Better Brain. Okay? So this is a brain without any lesions in it, and it's just used to overlay different files. In our case, we're going to overlay already drawn lesions. Okay, so first let's overlay the JGL lesion that is already pre-drawn, and if you scroll up, here's the JGL drawing guide for you to go step by step to draw the lesion yourself. Okay, so you can follow this as per part 1 of this tutorial series, but we already have it saved in the materials that you've downloaded, so you can go to Overlay, Add. We can go into the Lesions folder, so MRIcron Workshop, Materials, Brain Lesions, and then this Lesions folder, and we can select Lesion 1 JGL, click Open, and you can see that this is black here. So let me expand the MRIcron window some more, and if you go to this drop-down window here, you can select between either the background, so the CH2 Better Brain, or the Lesion 1 underscore JGL that I just opened. And this allows you to indicate which of the files is going to be affected by changing parameters. So we're going to change the parameters on Lesion 1, and we're going to change the minimum and maximum in this particular image, and we'll change it to minimum of 1 and maximum of 1. Because if we select on it, we can see that this is a binary file. So if you go up to the top left here, you see the intensity values of the underlying brain, so of the background brain, which is the CH2 Better Brain, and then you see the intensity values of the overlying brain that we just added, this Lesion 1 JGL. And we see that the lesion file has an intensity value of 1 here, and if we click anywhere else where it's not red, we see it's 0. This file just has zeros and ones in it. But next, we want to add another overlay on top of the one we already have. So go to Overlay, Add, and we'll select Lesion 2 this time. And now we'll see that this lesion in blue, and we'll see the intersection is in magenta, and we'll see the original Lesion 1 is in red. If you don't see the intersection of the two lesions in magenta, you can go to Overlay, Transparency on Other Overlays, and select Additive. So in going to a voxel where there is an intersection, you can see up here at the top, again this 98 is the underlay intensity value, and these are the intensity values for both of the lesions. If I go to just the blue portion, you can see that here the 0 is for the Lesion 1 overlay, and the 1 here is for the new overlay we just added, the blue one. And you can change the colors of these overlays by selecting the appropriate overlay And so at this drop-down menu, you can change the colors of either, in this case, lesion 1 or lesion 2. And let's say we want to change lesion 2 to green. We can go over to this color scale drop-down menu and select green, and now it's changed automatically. So we can go to change it back to blue. Okay, the next thing we can do is to actually combine lesions into one map. So if we go back to our instructions, we can first combine all the lesions. So to do this, let's close the overlays we have, and now we can go to Draw and Statistics, and we'll select Create Overlap Images. So now we can combine all of the lesions, and to do this we go to Draw, Statistics, Create Overlap Images, and now we can select all the images we want to combine. So the format of these files are in the nifty format, so you want to change the format down here to neuroimaging, and now we'll see the nifty formats. And so these are all the lesions. Again, they're in the brain lesions folder, and you'll select one, and I'm going to shift and left click to select all of them, and we'll click open. And now we have a new file that we can save. And I like to keep the format as nifty for all my files, and so I'm going to change this file name to Lesion Summary 6. So this is a combination of all the 6 lesions that we have here, and I'll click Save. Okay, and you can see what this combination looks like right here. And so let's re-overlay it. So I'm going to go to Overlay and Close Overlays. Now I'm going to go to Overlay and Add, and I'm going to select the summary that I just made, so the Lesion Summary 6. Again, it's in black, but we can select the Auto Contrast, and we see that this doesn't work very well for this combination. So we can set the minimum and maximum to 6. To make this more clear, we can change the color scale to something more pleasing, such as spectrum, so this hopefully is a little easier for you to view. Let's explore this overlay map, and one way to do is just to left click up at the top of the brain and just scroll down. So hold the left click and just scroll down, and we can find the areas of the greatest overlap, and it looks to be these teal and light green voxels are the areas of greatest overlap. And we can look up here at the top. You see again the 111 is the underlay intensity, and the summary file intensity values are here. So in dark blue you see this is associated with a value of 2. In order to see the maximum overlap more clearly, you would want to set the maximum value to the maximum intensity value in the image. And so the maximum doesn't seem to be 6, and so we can decrease this progressively until we have a very clear image. And so here we see in red, after we've set the maximum intensity value to 4, we see that there's in these red voxels here do have a value of 4 as the maximum. And if we want to isolate only the voxels with the maximum, we can increase the minimum. And so now we're only seeing those voxels which have a maximum value in this lesion overlap image. And we can check, there might be a few voxels that have a maximum of 5, and so if we increase this to 5, we can left click at the top and scroll down and see if we see any voxels that have an overlap of 5, and we don't see anything. Okay, so the maximum is 4. Back down. So this is one way to determine what's a good setting value for any lesion overlap map that you're using. Okay, the next thing we want to do is combine specific patient pairings. So in the materials that you've downloaded, there are specific pairs of these patient lesions that go together. And by go together, I mean that they have shared cognitive deficits. In the materials that I've included, so So in the Brain Lesions folder, as noted here in part 5.4, lesions 1 and 2, lesions 3 and 4, and lesions 5 and 6 common pairs, and they have shared cognitive deficits that the other pairs do not have. And at the end of the video, I will go over what these deficits are. So the combination of all the 6 lesions that we just looked at, it was really just an exercise for using the tool. It's not super informative because all 6 of these patient lesions do not share the same cognitive deficits. So to compare pairs of lesions, what we're going to do is essentially what we did with all 6, but select just 2 images to create these pairs. So I'm going to go into MRIcron and close the overlay. I'm going to go to Draw, Statistics, Create Overlap, and change the format to neuroimaging. And I'm going to select lesion 1 and lesion 2, and we'll change the name of it to pair 1, change it to Nifty format instead of the Nifty gzip. Save. Okay, so this is what you'll see, and you can close this overlay, and now we'll do it for the other 2 pairs. We'll go to Draw, Statistics, Create Overlap, change the neuroimaging format, select lesions 3 and 4, change it to Nifty format, and we'll go pair 2, save, and we'll close this overlay, and now we'll go to Draw, Statistics, Create Overlap Images, and then select lesions 5 and 6, and we'll change the name to pair 3, and use the Nifty format, click Save. I'll close this overlay. Okay, so we've generated 3 different lesion summary maps based on the 3 pairings we have. Okay, the final thing we want to do is overlay all of these lesion pairs that we just created. To do this, make sure you have the CH2 Better Brain loaded up, and we're going to go to Overlay, Add, and we can choose all of these 3 pairs that we just made, or if you skipped ahead, you can go into this summary folder and select all of these pre-generated lesion pairs. But we can select the pairs that we just made, so I'm just selecting all 3. We're going to overlay all 3 of these images simultaneously. And you'll see, as if I'm left clicking and then scrolling down, you'll see it's a bit of a mess and it's not clear which lesion pairs are associated with which colors. So now we need to go into this drop-down menu and select each of the pairs in turn and change the colors to something a little bit more clear. And in the instructions, we're going to change the colors to red, blue, and green respectively. So for pair 1, we're going to change it to the colors to red. And for pair 2, we're going to change it to blue, so it's already set to blue. For pair 3, we're going to have it set to green. So it's still not super clear. In order to isolate the regions that are really unique to each of these pairs, what we need to do is change the minimum and maximum values for each one. So let's go back to pair 1, and let's change the minimum now to 2. And we can change the maximum to 2. So if we go here to red, this is the region where both of these lesions in this pair are present. And now let's do that for pair 2, and let's say the minimum max to 2, and we'll do that for 3, minimum max to 2. So now if I left click up at the superior portion and scroll down, we can see it's a little bit more clear which regions are associated with consistent damage for each of these pairs. And another way to view this is to use the render tool. So we can select Window, Render, and this will generate a three-dimensional image of the brain. It might take a while, depending on your computer. And so this now, by default, on my computer, it's set to look at the base of the brain. What we want to see is a left profile view of the brain, because the lesions are on the left side. We can change this by changing the azimuth value to 270, and we'll change the elevation to 0. So now we can see the left profile view, and we can say left click on the screen portion, and it'll jump to the surface of the slice view where we have the sagittal, coronal, and axial slices. It'll jump to that depending on where we click in the rendered view. Working with this allows you to gain a better sense for where the lesion is on the profile view, so the surface of the brain, a surface rendering, relative to where you are in the slice view. If you aren't seeing these colors clearly, you might need to go into Overlay and search any depth, and that means it's going to search all throughout the brain for the specific color. If you search just below the surface, what this does, it'll search at a search depth of, in this case, 16 voxels for whatever color associated with the different lesion pair files. Okay, so this gives a nice summary view of these different lesion pairs. So if you want to identify what brain regions are associated with these different lesion pairs, we can open another MRIcron window, and so we can right click on the icon down here, select MRIcron, okay, and now we can go to File, Open Templates, and we can select the AAL atlas, and you'll see it loaded here. And we need to make sure that these windows are yoked, so go to View and select Yoke, View and Yoke in the original window. Okay, so when you click on one, the other window will follow whatever coordinate that you're clicking on. For instance, if we select the blue region, we can see that the insular cortex is damaged, right? So in blue, that's damaged, and the superior temporal gyrus in the left hemisphere is also damaged, so that's what this name means. And click around to identify other brain regions that are associated with the damage that we see here, the consistent damage for these pair of patients in the blue. We can go to green. You can see that the left inferior frontal gyrus is damaged. And we can click here down in the red and see that the left inferior temporal gyrus here in green and the fusiform gyrus in the left hemisphere is also damaged in this pair of patients. So there are other atlases that come with MRIcron or that you can find on the internet and download yourself. The AAL atlas is a good option. There's also the Brodmann area atlas that you can use to identify which Brodmann's areas are associated with these lesions, or you can go to the Harvard-Oxford Atlas is another good one to use. Another option for using these atlases is to actually overlay your lesions onto it, and so you can open a particular atlas and go to Overlay and Add, and then let's say I select pair 1, and we'll see that the lesions overlay here, and I'll change these settings as I did previously. I'll change the minimax to 2, and now we can see in red here these lesion pair overlaid on the atlas itself. To make it even more clear, you can go to Overlay and go Transparency on Background and change it to say 60%. And so now you can see the underlying atlas and the lesion as well. So we can see this outline here. And you can play around with these settings to get a good view that lets you identify the brain regions associated with your particular lesion pair. So close overlays. Okay, so the last thing I want to do is go over which cognitive deficits are associated with these lesion pairs. So as I promised I would do. So I'm going to go to Window, Render. Generally speaking, the two patients here with brain damage that is consistent to this region, they had spoken production deficits. So this is also termed Broca's aphasia. So this tends to be found in individuals with damage to the left inferior frontal gyrus. So damage in the blue regions, consistent for the two patients here, they had spoken comprehension deficits. So they tend to have difficulty understanding spoken communication, what individuals are saying. And in red, these are associated with impairments in written language. So it's associated with reading and with writing. So these lesion pairs are associated with a set of individuals with language deficits, but different aspects of language, either the spoken production, the spoken comprehension, or written language. So in these two videos, part 1 and part 2, you've learned how to draw lesions, you've learned how to overlay them, and learned how to identify different anatomical regions, and you have a basic idea of how we can associate certain impairments in cognitive functions with brain lesions. So this is a very, very basic introduction. Researchers will combine multiple different lesions, dozens if not hundreds, to draw inferences about how cognitive deficits match to certain areas of the brain. But hopefully this gives a good introduction so you can conceptually understand where the data comes from and how it's interpreted with respect to more advanced analyses.